Welcome back to my channel. So, I finally took the plunge and started an Android project. Installing Android Studio wasn't exactly smooth sailing. I ended up having to download the latest version manually from the web. And honestly, I've already blocked out the specific headaches I ran into during the install. Starting the project was just as rocky. I'd get halfway through coding only to realize something was missing or a file couldn't be found. If things look smooth now, believe me, it didn't start that way. Anyway, let's open the project. Most tutorials tell you to start with a totally empty project. But I couldn't do that because I didn't know what I was doing. I needed at least some layout to look at. I actually tried a blank project first, but I had no clue how to add the UI. You can add new pages and components without a UI, but it makes the layout way harder to manage. I tried adding a screen later, but I couldn't figure out how to move the main program over. That's just me being a newbie, not a bug in the software. Even the naming conventions threw me off. Usually, I start file names with numbers to keep them in chronological order. But Android Studio kept complaining. So I had to cave and use traditional naming. The default language was Kotlin. I'm actually more comfortable with Java. But after failing to fix the conversion a few times, I realized it's just easier to find resources if you stick to the defaults. So, Kotlin it is. I did read that Kotlin is better for cross-platform stuff. Like, you can even use it for iPhones. Though I'm not really interested in that. The project structure looks clear enough at first glance. Everything is under the app src main directory, and there's a test folder too. Our main work happens in main. It feels a bit like Java where the directory path is super long because it's based on your domain name. But the second you close it and reopen it, it looks totally different. You can't even tell what's what from the regular file explorer. First, I had to set up my JDK in the config. I'm not a fan of the idea that if I don't have one specific program installed, then Java just won't run at all. I prefer using a standard Java environment because compilers built into specific apps usually cause issues. I remember debugging Python once where different apps use different environments. I've had clients tell me that during debugging, a package they definitely installed was nowhere to be found. So, I eventually had to set up a totally separate, independent environment just to make sure the resources were reachable. It's much better to have an independent environment from the start to avoid those dependencies. Next, I fired up the emulator. Most frameworks are designed so that the project can run immediately after creation, even if it's just a blank screen. Then I opened the UI layout. Since I chose this project version to get a template, I figured I'd draw something on it. I'm so unfamiliar with this tool that I didn't even know how to add images to the directory. I just did what people suggested, dragged them straight from the file explorer into the IDE. A dialog pops up asking what you want to name the file and where to save it. Once you know the path, you can just copy files there directly in the future. I dropped in 3 images and started on the interface. The layout is stored in an XML file, which is basically a nested text file. It's like HTML. But while HTML has fixed tags for things like web pages, XML lets you define your own tags, which is great for keeping records. The layout XML is in the resources folder under layout. You can view it in 3 ways, a graphical design mode for drawing. The second is a split mode with picture view and text definition. It's convenient for developers when they need to specify the component name or connect it to other components. You definitely need the text editor sometimes, otherwise changing the UI can be a real pain. The third is full text mode. In design mode, the left side has a palette where you pick things like buttons or an image view. I dragged an image view over and picked my image. Then comes the constraints. If you don't set these, the computer just stacks everything one after another. Without setting the distances, your margins won't look right. I dragged the 4 sides to the corners to position it, though I later realized it doesn't always stay perfectly in place because every phone screen size is different. After the image, we see this default text sitting right in the middle. At that point, I switched over to the split design text view to check what the actual object name for that text was. We can see that even for a piece of text as simple as this, it's still got a whole bunch of attributes. I added a button, mostly just so I could figure out exactly where you go to change the text on it. I'm skipping a lot of the next part because I ran into a ton of bugs that I had to fix. Basically, my goal was to port that Python tool I made, the one that reads text, over to Android. I looked into tools that package Python into an APK, but I realized doing it natively would be less work in the long run. Plus, I'm not a fan of WebView performance. Trying to pack a simulated server into a phone seems inefficient, so I coded it natively for Android with some help from AI to explain things I didn't understand. Once I had the background image, I needed a button to open files. I ended up making an image button for playback. When a file finishes loading, the image changes from a flower bud to a full bloom. I also added a text button for loading, a stop button, and a delete button to clear the cache. There's also a space to input line numbers. One thing that's a bit different is that I added a list view right at the bottom. Because when I first started debugging, I couldn't tell if the app just wasn't reading the data at all, if something was breaking during the parsing process, or if there was some other random issue going on. So, I set up a separate list view just to confirm that the content was actually being read and that the whole parsing process was working correctly. But while I was testing everything out, I actually ran into a few other annoying problems. I hit some snags during testing, though. When you save a web page as a file, images get embedded in it. I mean, there's really no need to scan the image sections. I'm 100% sure that I only need the parts that are actually readable and understandable. So, honestly, I don't even need the content inside the image tags. I asked AI to help filter the text, but it got too obsessed with perfecting the filtering process while leaving unreadable junk codes in. It was super annoying to listen to. Eventually, I checked the file myself and saw clear tags for HTML, CSS, and images. I realized that just ditching everything except the actual HTML content made things way faster. Once I stripped out the JS, CSS, and image data, the text processing became lightning fast. To save even more time, I added a save button. Every single time you load a file, the program has to run through the entire content all over again. Especially back when it was still trying to analyze the image data too. It would take forever just to read one file. So, I went ahead and made a save button that takes all the parsed content and saves it as a simple text file. Next time, I can just load that txt file directly and skip the parsing entirely. Now that the project is mostly done, how do I get it onto my phone? Back when I learned C, you'd just package everything into an executable. Python is more free because it uses an interpreter. You can leave files scattered around as long as the program can find the entry point. PHP is similar. I used to be really familiar with PHP too. That's because I was developing for 2 different platforms. One was a standalone desktop platform, and I was also doing a lot of web-based stuff. The architecture of PHP is actually a lot like Python. As long as the program can find the entry point, it doesn't really matter if your code is scattered all over the place. But on a phone, you expect a single file to download. So now, the entire framework has to be bundled up into one single file. The core thing about using an IDE is that it has a build functionality. It basically takes all your separate files and bundles them into one single file. So, I built it. At first, I couldn't find the file. Then I realized it was a debug version, which wouldn't work on my phone. Generally speaking, in C, the developer is the one who controls the differences between the debug and release versions. And usually, those differences aren't big enough to keep the program from actually running. Mobile systems are much stricter. I found I have to change settings to build a release version and started packaging. I did that and sent it to my phone. But it still complained that it was an unauthorized APK. It basically warns you that the file is unsafe because it's not from a reputable company. Even though I signed it with my own key, the warning was still there. It took me a while to figure out how to create a key and sign the app. In Android Studio, you have two options: Bundle or APK. The Bundle version is for the Google Play Store. It's smaller because it doesn't include resources the Android OS already has. If you're planning to sell your app, the Play Store is the way to go, even though you have to pay a fee. But for a personal app, or for users who can't access Google, like in China, a standalone APK is the only way. Since a standalone APK doesn't rely on system-integrated resources, the IDE packages everything more thoroughly. In places like China, where multiple companies develop their own versions of Android, bundles are often useless because there's no single centralized management system everyone relies on. So, why do so many people still join the Google Play Store? Because Google's Android ecosystem is still incredibly powerful. Some developers create one masterpiece and then fizzle out, or their work gets so popular that they lose control over the derivatives. Sort of like how different versions of Linux vary so much that even basic commands are different. Back to Android Studio. To make a standalone APK, you need a developer key. If you're selling an app, you want a consistent identity so investors can track your history and see that you've been performing well and aren't just stealing code. You have to set a password for the key file and a password for the app itself. So, 2 passwords total. I signed the app and generated the APK. I thought the phone wouldn't object to a registered app, but it still did. I sent it to my phone via the cloud, and it finally looked like it did in the emulator. Well, similar, because as I mentioned, UI constraints behave differently on different screen sizes. Some things overlapped on my phone even though they looked fine in the emulator. I had to tweak the source code to get it looking right on my actual device. One last surprise: file structures on mobile are different from desktop. I didn't realize people still used MHTML, but it's basically the standard for saved web pages now. On a computer, saving a page usually creates an MHTML file and a separate folder. But on a phone, it's just one MHTML file, and the sections are labeled differently, which messed up my text filtering. But hey, I fixed it. Congrats to me, my first Android Studio app is officially done. That's it for now, see you guys next time. Bye.